Perfect. Right. So let's see what the next set of questions are about. Right. Did we do these questions as yet? Just refresh my memory. To my knowledge, we did not do it, but check in your notes and let me if we did these questions already or not. Right, great. So a lot of people are saying no. So before we start the questions, let me just refresh your memory. This basically means when we have brackets and we have powers, right? So for example, if we have 4 and in brackets, we have a squared outside. How brackets usually work is that everyone in the brackets gets subjected to whatever is outside the brackets. But if you have one item in the brackets, well, there's not much maths to do there, meaning that the squared belongs to whatever's inside the brackets. So this is the same thing as 4 squared. In other words, we just wasted ink drawing these brackets. However, if you have more than one item inside the brackets, for example, you have the letter X and you have the letter 4. So you have 2 items in the brackets and you have a squared outside. This means everyone inside the brackets gets what? Squared. So you can rewrite it like this. X squared 4 squared. You see what happens? The squared gets applied to everyone inside the brackets. So you can also rewrite it like this. Now, quick question. You see how I have 2 items here, an X and a 4, based on the homework videos. If there's nothing in between the letters, the number and the letter, what is understood? If you see 2 things together in maths and you see nothing in between, what do you have to assume? Right, Elijah, great. Right? Anybody else? What do we have to assume? Right, Nalini and Taylor, correct? You have to assume it's a secret multiply. Always, always, always in maths. Now, I want to go through one of the most common mistakes made in maths. I'm not only talking about Form 1 and Form 2 and Form 3s. I'm talking about Form 5s, people who leave school and in university. Let me show you one of the most common mistakes, right? Let's say the same situation. Let's say we have 3y and we have the power 4. I just showed you that this power belongs to everyone in the brackets. So it's okay to say 3 to the power 4 and y to the power 4 because it's a secret multiply. What about if it was a divide? So let's say we had the letter K divided by 5, and it's a divide this time instead of a multiply. And I put this whole thing in brackets. And I have to the power, let's just call it 6, right? The whole thing is in brackets. So that means that power, the 6, belongs to everyone inside the brackets. So it is okay to say K to the power 6 divided by 5 to the power 6. You see, the 6 gets applied to everyone. So this is correct in maths, and this is correct in maths. And usually teachers like myself will show you this first. But then, remember I tell you, there's a very common mistake made in maths. So then one day in the exam, you see this. You see the letter K or the letter Y or whatever, you can use any letter, plus 7, and then you see a power 4. Now, obviously, based on what I just said, if you have some items inside the brackets and you have a power outside, common sense will say, hey, that 4, that power 4, belongs to everyone here. So you know what a lot of people will do? And tell me, and be honest, how much of you all were thinking this even before I said it? This means k to the power 4 plus 7 to the power 4, because the 4 is outside the brackets. And I have been saying when you have something outside the brackets, it belongs to everyone inside the brackets, right? And I used to think so too. I used to think this was correct, but this is actually wrong. And let me show you another wrong situation, and then I will explain why it is wrong. Let's say now you have x minus, let me just say 8. And outside the brackets, you have what? Let's put a cube. The cube is outside the brackets. So you will say x cubed minus 8 cubed. But this is also wrong. Let me explain why it is wrong. You see this thing with the powers and the brackets? Like when you have a power and its brackets, it only works for multiply and divide, right? It does not work for addition and subtraction. So it does not work for addition and subtraction. It only works for multiplication and division, right? Everyone is okay with that? It's real easy to fall for the trick because you see the subtle differences, right? It's almost like common sense doesn't even apply to this situation. I want everyone to take down the correct versions and write down exactly what I have in yellow here, and take down the wrong versions and put a big wrong sign. Okay, let me know when you are finished, right? And we will start the worksheet above for you. In the first question, well, A, obviously, right? A is what? A, B to the power what? 4. Can we apply the power to both of them in this question? Is it okay? Both items are in brackets. And of course, if there's nothing in between here, there's a secret what? Multiply, okay? Now, in case you can't remember, we will be using this rule here. Let me see if I can find the rule. Oh, keep your eye on this rule over here. Let me just help you to refresh your memory on that rule. That rule says that if you have x to the power 2 inside the brackets and you have another power outside the brackets, whenever you have two powers separated by brackets, it's okay to multiply them. That is what this rule is saying. So 2 multiplied by 3 is 6. Now, this one here, because it's multiply, right? You can apply the 4 to both of them. So the 4 can go here and the 4 can go here. And that's the answer. That you'll get full marks. But let me do this question the long way with all the working. If I have A, you see how this X here has a power? Does this A have a power? Looking at it, did the examiner put a power directly over the A or over the B? Did he directly write it in? No. Whenever something does not have a power, you have to assume the power is always 1. And of course, this 1 is separated from this 4 by a bracket, and this 1 is also separated from the same 4 by a bracket. Remember, when powers are separated by brackets, you can multiply. So 1 multiplied by 4 is 4, and 1 multiplied by 4 is our next 4. But that's the long working, all right? So if you wanted to do it like that in your head, it's okay. So the answer for the first one is A4 multiplied by B to the power 4. Part B isn't that much more difficult. I'm not too sure why I even bothered to put it in. X and Y, there's a secret multiply. So, and this is really x to the power 1 and y to the power 1. So this one is x to the power 3, y to the power 3. 1 multiplied by 3 is 3. 1 multiplied by 3 is an x 3. I would like you all to try part C. This is where the tricks start to come in. Try your best to simplify part C. Send your answer on the chat. You don't have to be shy about getting it wrong. Only I can see your answers. And I prefer you try and get it wrong, and you're brave enough to send the answer rather than not send anything and wait for me to do it. So I'm going to do part C several ways. Well, a couple of 2 ways. I shouldn't say several, 2 ways. In maths, did you all know, well, I show you a bunch of this in school. Whenever you have something on top of a divide sign and you have something underneath the divide sign, let me say I have 2, sorry. Let me say I have 2 on top. But let me just say 2 underneath, and I have 2x underneath. You notice that there's something on the same on top and the same underneath. I think everyone is familiar that the 2 and the 2 can cancel out, because 2 into 2 is what? 1, right? So I think most people will understand that rule, okay? If you have something similar on top and similar underneath, they can cancel out. Also, if I have 5 squared, we all know this is 5 multiplied by another 5, right? So some basic rules over here. So I'll leave this on top. For part C, I have 3 on top and 3a, but here's the thing. The underneath part alone is being protected by brackets. Now, whenever something is being protected by brackets, pretend that it's not accessible. It's almost like a force field, and no one can enter that force field because it's a force field, right? It's for protection. But we know from what I've been saying all the time, if everyone is inside here, sorry, if this is brackets and you have a squared outside and it's a multiply, that means it's okay to say 3 squared a what? Squared. And to continue this working, 3 squared is the same thing as 3 multiplied by another what? 3, and then you have the a squared. Everybody with me so far? I just apply the square to everyone here. And then I said, hey, 3 squared, just like how 5 squared is 5 multiplied by 5, I can say this is 3 multiplied by 3. Everybody with me so far? Right. Now, some people are sending the answer a little bit wrong, right? Now, isn't there some similarities on top and some similarities underneath? It have a 3 on top and 2 3s underneath. Won't it be possible for one of these 3s to cancel out with one of these 3s? It can't cancel out both because it's 1 for 1. So you're going to end up with 1 divided, but this 3 is underneath. Some people put in the answer like this, 3a squared. Is 3a squared the same thing as 1 divided by 3a squared? No, that's completely different, right? So this is the final answer, this pink answer here, because one of the 3s on top got canceled out with one of the 3s underneath. So to me, this is the form 1 way of working it out, right? The long way without using any indices rules. You notice we didn't use any of these rules here, right? Right. Now I want to point out something, right? Somebody had a mistake. Right. So Javon, I'm not too sure how you got minus 3a squared, right? But let me know when you finish taking down over here. This is 1 divided by 3a squared. Right. And I just want to help you uncover some mistakes here. I know I will take my time, but you see all these little things will help you from now to the end of Form 5. So let's just get over with. Now, I want you all to look at this rule here. All right. Remember what that rule is saying is that if you have x to the power of 4 minus 4, remember last week I told you all, nobody likes a negative power. I have no problems with negative powers, but some people find the minus sign is just make it look too complex. So if you do not like a negative power, not a problem, you can throw the whole thing underneath a 1 and you will get what? A positive power. Remember that from last week, right? And similarly, right, if for some reason I have 1, I got a different color here. If I have 1 divided by y to the power 7, and this 7 is underneath, isn't it possible for me to write it like this? I could throw it back on top and the power becomes negative. Let's say I have a problem with positive powers and positive powers is getting me mad. So I decide to throw it on top. So it changes back to a negative. It's like reversing this procedure. It's a reversal. Everybody with me so far, right? But you don't respond to that, but I'm hoping you're with me so far. So let's move back to here. I would get this 100% correct in the exam. But there's another answer to this. Let's say for some reason, again, this positive 2, you see how this power is positive and is hovering over the A? Let's say that annoys you. What you can do is this. You can take the A squared and throw it back on top. And you will get A to the power minus 2. But the 3 remains underneath. A lot of people, when they grab the A, they just grab the 3 by mistake. And the 3 will go on top. No, you're grabbing the A squared alone. So the power changes to negative. This is also mathematically correct, but I would prefer if you left it at this point. Because which one looks more pleasing to the eyes? So which one looks easier to deal with? The pink one. The minute you start to see negative powers, to me, students will start to shut down. All right? So let me show you another way of doing part C, and we can get the same exact answer over here, right? Let me show you a different way. Let's say you wanted to use these rules over here to get it out. So you have 3 divided by 3a, and in brackets, the whole thing is squared. So, all right, you put back the 3 on top. We know the squared can be applied to anyone here. Remember, 3 is the same thing as 3 to the power 1. Now look at this. I run out of space here. You have 3 to the power 1 divided by 3 to the power 2. Remember this rule here? When powers are being divided, you can minus the powers. So you have 3 to the power 1. So let me work out this part here. 3 to the power 1 divided by 3 to the power 2. Since it's a divide, you put back the 3. You take the top value and minus the underneath value. Based on your homework, without your calculator, how much is 1 minus 2? Get the sign correct. I want to know if it's positive or negative. Because according to these rules, if we divide in 2 indices and the bases are the same, we can minus the powers. How much is 1 minus 2? Let me see if that simple question will trick you all. 1 minus 2 is how much? Right, Faith, correct. Samia, right, correct. And this is where your homework comes in, right? You can get out positive and negative addition and subtraction real easy. 1 minus 2 is minus 1. You can check it because the 2 bigger than 1, right? So this is what will happen. When you simplify this situation, you're going to get on top minus 1 because 1 minus 2 is minus 1. And you're putting the answer on top and not underneath. And you're left with who underneath? 3 squared. But look at this. You end up with a negative power hovering over the 3. If you don't like that, you could throw it back underneath And remember, if I don't put the 1 here, it is understood as positive 1, because when you throw it back underneath, the power becomes the opposite. The negative 1 will change to positive 1. And of course, you don't have to put the 1 if you don't want to. Either way, you get the same answer. You realize any way we do it, we get in the same answer. So take down the second way of doing it. Sorry for the scattered working, right? But this is the working that will accompany this. Let me know when you are finished, right? And we will start. I think it's real easy to do D, E, and F, all right? Now, D is pretty easy. You have a 2 and an A, and there's a secret multiply. We know this is 2 to the power 1 and A to the power 1, right? So this is all the powers here get multiplied by 3 because the powers are separated by brackets. So you get 2 to the power 3 and A to the power 3. Now, mathematically, this is correct, but and we could simplify this a little more. Because, and we could easily work out 2 to the power 3. 2 to the power 3 off the top of your head. Last week, I gave you a table to learn off. How much is 2 to the power 3? Please don't say 6. The answer is not 6. Because it's 2 by another 2. It's 8. 8a cubed. The examiner will want this one, right? Even though this is mathematically correct, it's real easy to work out 2 to the power 3 in your head. So the examiner will kind of want that, okay? All right. This one here, the powers are 1 again, and it's a secret multiply. So all the powers get multiplied by 4 because that 4 belongs to everybody in the brackets. You're getting 3 to the power 4, y to the power 4. This one is real easy to simplify. Remember last week I gave you a chart without looking back. 3 to the power 4 off the top of your head. Yeah, right, 81. Right, great. And don't forget the y to the power 4. And this one is also easy. This squared only belongs to the n, right? This m, the power is how much? 1. So you get 1 by 5, so you get m to the power 5, and n, 2 multiplied by 5 is 10, right? Remember, all the powers are going to get multiplied by the 5 because they are being separated from each other via brackets. So take down the answers and we're moving on. Of course, in case you forgot, we're trying to leave the city because of the explosion. We will continue the story in a few seconds. Right, another person said they got all correct. Let's see what's next on the little show here. Right. So you can imagine this, right? That there's what? If there's a huge explosion in the city and everybody is trying to leave, you can imagine the amount of chaos that's going to have in the city there. Right, so there's total chaos in the city. It's a good idea to get out. Looting and whatnot. All right, so we have some more questions here, right? Let me work out part E for you all, so you can get an idea of how to do it. If I have the letter Y, according to the homework, how much Y is that? Is that 1Y, 2Y, 3Y? Like, you know, I could write 2Y, right? I could have 3Y. But if I have plain old boring Y, how much Y is that? Correct side. It's automatically 1Y. And of course, if you had to put a power, like how there's no power, the power is 1. So it seems in maths, whenever you have a letter or something by itself, and there's no number to accompany it, whether it be a power or something in front, the default is always 1. When you all were doing the homework, how much of you all clearly realized that addition and subtraction had completely different rules to multiplication and division? I was trying my best to portray that in the 7 videos. Well, that's from videos 1 to 4. It's not even up to 7. Even if we reach up to video 3, you will have realized that is what I was trying to portray. Multiplication and division, completely different to addition and subtraction, right? And when you all were doing multiplication and division, I had introduced something called N, L, and S. Because when it comes to any maths question, almost every maths question has 3 things involved: numbers, letters, and signs, right? Like X and Y, that is letters. Numbers is like everybody know what a number is. And of course, signs are either positive or negative, right? And I have everything here just in case you all forgot, right? Everything. The first question here is a multiplication question. So we're paying attention to the multiplication rules. Do not mix it up with addition and subtraction. So in part A, when we have actually, I need more space there. In part A, when we have 2a squared multiplied by a to the power 3. You see how this a squared has a number in front, and the examiner was stingy and he did not waste ink to put a number here? Well, you have to know better than that, right? You have to know it's a what? 1. So using the multiplication and division rules, let's multiply the numbers first. 2 multiplied by 1 is 2. What's next on the list? The letters. Now, you're already seeing a squared multiplied by a to the power 3, which is this rule here. Remember last week when we were multiplying indices, if the bases were the same and it's a multiply, that means you can add the powers. Do not make the mistake and multiply the powers. As common sense will say, hey, we multiplying the bases, so let's multiply the powers. That's wrong. You add the powers. How much you think you'll get here? What value do you think I have to put here? I'm adding the powers. So I'll put back the a once. And what am I putting here? 5, right? Because 2 plus 3 is 5. So that's the answer for the first one. 2a to the power 5. And this 5 only belongs to the a. It doesn't belong to anybody else. So multiplication means you're adding the powers. Division, once again, means you're minusing the powers. I want everyone to try all of them. Take a couple minutes, try your best. This is multiplication and division. Do the numbers first. Do the letters after. And if it have any signs, you can do the signs last. Remember, if you're multiplying or dividing 2 positive, you still get back a positive. Now, all the rules here, everyone should be familiar with them by now. That was the purpose of the homework. And this one was pretty easy. Remember, this x squared doesn't really have a value in front, and we multiply it. So we do the values first, right? 1 multiplied by 3 is 3. You have x and a next x and a multiply. So you're supposed to add the powers. So I'm hoping you get 6 here, and I'm hoping you didn't put 8 by mistake, because it's easy for your brain to say 2 multiplied by 4 is 8 now. But you're already supposed to add the powers. C, do the values first. 2 by 3 is 6. And y, and I multiply. So again, y to the power 4. 2 plus 2 is 4. Small, not even a big trick. Very, very small trick. We divide here. 8 divided by 2 is 4. And here we have powers, but this is really x to the power 1 because the examiner did not give us a power. So divide means we have to minus the powers. So it's 2 minus 1, which is 1. Now, how we end up with positive 1 here, we can put the 1, but if you leave it out, it's still correct. Because if you leave it out, the default is it will still be 1. How much of you all got the 3 on top correct? All three correct. Right, and this one is almost the same, I guess. You're dividing the values first, so you get 5. Here's 3 minus 2, so you get a 1 again. Obviously, putting the 1 here is optional. 6 divided by 3 is what? 2. The z's are the same and they have the same powers. Divide means to minus the powers. So 4 minus 2 is 2. This one here had a slight trick on it. Okay. 10 divided by 5 is 2. Let me see if you all got this correct. So yeah, the y and the y are the same, and it's a divide. How much did you all get for the power? How much did you all get for the power? Alima, no, check it back. Divide means to do what? Minus the powers, right? It's a divide, right? No, Maria, check it back. Like if you're not hearing your name, that means you have it correct. Destiny, check it back. Right, Kayla, correct. Remember, it's the 2 come first, and then it's the divide. So divide means the minus, and then you have a 3. 2 minus 3 is minus 1. So you could put the minus 1, or if you want, if that minus sign is bugging you and it's making you angry, you can throw it underneath the y alone, because this minus sign only belongs to the y, and it becomes positive 1. And of course, you don't have to put what? You don't have to put the 1. Once it's positive 1, you don't have to put anything. So this is correct, or this is correct. All right? Right, so that's supposed to be Port of Spain there, right? You all see the little tower, the little cathedral in Port of Spain there. All right. All right, so they're trying to evacuate everyone from Trinidad right now, but the evacuation point is quite Cedros. You have to reach Cedros somehow, and once you reach there, they'll evacuate you all to Venezuela. All right, so something really bad is going on in Trinidad if they have to start evacuating everyone to a different country. Yeah, somebody noticed the number plate here. All right, so we'll see what's going on in a little while. All right, so now let's get started with these questions. In video around, I believe video 3, not even far into the homework, I started to introduce brackets. Like if you have 2x plus 3, I think this was the simplest example, right? Now, this is not dealing, what I'm about to explain, it's not about having a power outside the brackets. Tell me if what I am doing is correct based on my explanation about 15 or 20 minutes ago. Since everyone here is in brackets and we have a power, is it okay to apply the power to everyone? So you could say 2 to the power 7, x to the power 7 plus 3 to the power 7. Is that okay? That is 100% wrong, right? I know I mentioned that just now, right? Because this is addition and subtraction. I mean, if it was 2x, and let me just say I had a 3 here, and there was nothing in between here, yeah, no problem here, right? And if there's nothing in between everyone, fine. And if everyone is a multiply and you had the 7 here, well, fair enough. You could say 2 to the power 7, x to the power 7, and 3 to the power 7, and that would be correct because it strictly multiplies, not a boldface addition and subtraction in between the items. But I want you all to know the difference between this situation. I'm going to write back the pink situation a little bit different, right? This is totally different to this. If I had the 7 in front and 2x plus 3, is this a power? No, that 7 is not a power. In a case like this, I can multiply everyone in the brackets by 7. Not with the powers, but if the 7 was in front, it doesn't matter if it's addition, subtraction, multiplication, or division. You just have to make sure and multiply everyone inside the brackets by whatever is outside. So 7 multiplied by 2x is 14x, but you also have to multiply the 3 by the 7. 7 multiplied by 3 is 21. I had shown this in video 3, somewhere close to the middle of it. How much of you all remember this? To multiply out the brackets. You just take your time and multiply everyone inside the brackets by whoever is lurking on the outside. And it's okay to use the N, the L, and the S. You multiply the numbers first. 7 by 2 is 14. 7 by 3 is 21. Then you put back the letters involved. But this one really doesn't have much signs. A positive by a positive is a positive. A positive by a next positive is a positive. So the signs is not an issue in this one. So let me work out part A for you guys over here. So I'll write part A for those who taken on that note. So this is x to the power 3 on the outside, and inside the brackets you have x squared, right? Plus x to the power 4. Well, we multiplying everyone in the brackets here by whatever is outside. Now, lucky for us, it's a multiply. And once the bases are the same, you have to add the powers. So if we do that, x cubed multiplied by x squared is x to the power 5. Just in case you don't know how we got the 5, we multiply in these two. The bases are the same, so that means we have to add the powers. That's this rule here. Plus, we have to multiply him as well. X to the power 3 multiplied by x to the power 4 is x to the power 7. Sorry for the little squeeze there. Because we have to add the powers. 3 plus 4 is 7. That's your final answer. You cannot squish these two together to get one answer. That's your final answer. It cannot get simpler than that. You think you all could try B and C for me? For C, I'll give you a hint. Anything multiplied by 1 is itself. 10 multiplied by 1 is 10. A smiley face multiplied by 1 is a smiley face. So just do B and C and let me know when you are finished. All right, so let's see the mistake a few people made with part B. I think some people forgot like how you have this y by itself is really y to the power 1. And we multiplying because when you have something out directly outside the brackets in front, it's a secret multiply. So it's y to the power 5 minus y to the power 3. 2 plus 3 is 5. And 2 plus 1 is 3. For those who had 2 here by mistake, do you all understand your mistake? Quite a lot of people put 2 here by mistake. All right. You have to remember when you have something by itself and no power, you should probably put in the 1 so your brain doesn't, forget about it. The other one was pretty easy. It's a secret multiply on the outside. So everyone gets multiplied by whatever is outside. So again, z to the power 6, because we have to add the powers, because it's z and z, the bases are the same, right? And I noticed 1 was confusing people. but anything multiplied by 1 is itself. So z squared, and you have to multiply by the 1, it's still z squared. It's the same thing, right? Right? Some people put 1 here by mistake, but anything multiplied by 1 is itself. And you cannot simplify this, right? If it was a divide here, just saying if it was a divide, then you could have minused the powers, but it's not a divide, it's a minus sign, right? So with that in mind, let me do one of these questions for you in number 5, to give you an idea. In question 5, you notice you have 2 parts to this question. You have a numerator and a denominator. In case you forgot from primary school, the numerator is everything above the divide sign. And of course, the denominator is everything below the divide sign. Whenever you have a situation like this, take my advice. Work out the numerator first. Try your best to simplify everything on top as much as you can before you deal with the underneath. Do not try to deal with the above and below at the same time, right? That's a horrible idea, right? Handle the top separately and then handle the underneath. So let me work out that for you. In 5a, we have x to the power 3 multiplied by x to the power 4. Lucky for us, it's a multiply, and both of them are x's. Shouldn't it be real easy to simplify the top using this rule here? Because the bases are the same and it's a multiply, we can add the powers. 3 plus 4 is 7, divided by x to the power 2. So you see, the top is simplified, and now we just have this underneath to deal with. Lucky for us, it's a divide. That's this rule here. Divide means you can minus the powers if the bases are the same, and they are. It's x and x. So 7 minus 2 is 5. So the final answer is x to the power 5, positive 5. Easy enough. Try B. And of course, C has these minus signs. So let's see if your homework helps you out with the positive and negative numbers. Try not to use a calculator, because if you use a calculator, obviously you're going to get it correct. It's just to type it in. But you're not really utilizing the skills that you have learned in the video. Plus, in CXC, when you all reach there, for the multiple choice paper, you're not allowed to carry a calculator in the exam. So you have to learn to do it in your head at the end of the day. Right? So try B and C and just let me know when you are finished to help. All right, so I think B was pretty easy. I mean, it's almost the same thing like A, right? So if you work out the top here, everything is t's and the top is multiply. So I know we can add the powers. So on top we get t to the power 9. I realize some people put 18 by mistake because I know you're Russian and you're under a little bit of pressure, but we have to add the powers. 3 plus 6 is 9. And now you have t to the power 4. It's a divide, right? So you're going to get, what you're going to have to do now is minus the powers. Take the top and minus the underneath, and you're getting t to the power 5. Right? So I think a lot of people got that, right? And of course, well, now this is the final answer. I don't think you can modify that anyhow, right? It's the part C is what I'm worried about here. Right? Part C is what I'm worried about here. Those minus powers, minus numbers. So let me clear the screen and work out part C, right? All right, so W to the power minus 4. Right, so the top is multiply. So I'll work it out piece by piece here. Multiply means to add the powers. So it's 2 plus, and what weight in here? A minus 3. Now this looks weird, right? But I think I showed you all this in the homework. When an addition and a subtraction touch, like they physically come in contact with each other, what do you all get? The rules to decide here. When an addition physically touches a minus. Now there's a secret multiplier in between here. So you can think of it as a addition being multiplied by subtraction. What do you all get? If you look at the rules over here, look at this line here. When an addition touches a minus, you ultimately get a minus. So you get 2 minus 3 and divided by w to minus 4. So I'm running out of space here, so I'm going to go over here. 2 minus 3 is minus 1. We bounce that up over and over. How much people got the minus 1 on top here? Like you got the minus 1. Right? Because it's a positive and a negative touch. And once again, the multiply means you have to add. But you're adding something that is negative because of the values the examiner gave you. Now, this is where I think most of the mistakes occurred. The divide means you have to minus the powers. So you have minus 1 on top. Divide means you have to minus the powers. That is this rule here. But what waiting underneath? Another minus sign. So you end up with a minus and a minus. When 2 minus signs touch, you get what? Look at it. When 2 minus signs touch, you get a positive. So you end up with minus 1 plus 4. So when you use your rules now, minus 1 plus 4, use your addition and subtraction rules, you will get positive 3. Minus 1 plus 4 is positive 3. It comes like you owe somebody $1. A minus means you owe, and you have $4. So if you have $4 and you owe somebody $1, you give them the $1 and you're left with $3 for yourself. How much of y'all got this answer here, right? If you got it, feel real good about yourself, right? That means you went through that homework. You drill yourself to understand those positive and negative numbers, which is the core of maths. Everything, almost everything in maths will boil down to these positive and negative rules, right? You cannot pass maths without knowing them. Just. You all know where the bird sanctuary is? It's not too far from Port of Spain. If you walk enough, you could probably reach there in about 2 hours, if you walk. So the bird sanctuary is here, and the Caroni Bird Sanctuary is it's a river. So it will take you out to the Gulf of Paria. We just need to get what? Walk to here, take a boat, provided that there are extra boats at the bird sanctuary, and we can make it to where? The Gulf of Paria. And of course, once we make it there, we can sail, and reach at least in South Trinidad. Of course, once you reach here, you could sail to Cedros, but you're living in this area here, Princess Town. So you need to go and check your family first to make sure they are okay. And then you all can go to Cedros. That's the plan. Right. So let's see what's going on. Let's see what's going on with these questions. We're going to try to solve these questions here without using any algebra. The algebra videos, like solving for X and whatnot, begins at video 5. 5, 6, and 7 deals with solving for X. But we're going to try to solve everything here without using those things. Let me give you an idea of what's going on in these questions. In each of these questions, we want to solve for the letter N. You all ever had one of those puzzle books? Them kids puzzle books, like for real young children, and you have a little puzzle and you have to solve it. My son has one, right? So what it is they'll give you 2 pictures. And of course, something will be missing from one picture, and you have to use logic to kind of figure out what's missing in the other picture. So if there's a sun over here, and here has the same man, and here has the same man, what's missing from the box? Oh, don't overthink it. Please don't. The answer is not the moon. What's missing in this box here? Remember, this is made for like a 3-year-old or a 4-year-old. The answer would be the sun, because the man and the man in the same position. So what is missing here is the sun. Because if the man and the man is in the same position, then the sun and the sun, if the picture is supposed to be the same, should be missing from that box, right? Real simple, real simple. We're going to apply this technique to these questions over here, believe it or not, right? So in the first question, part A, you have 2 to the power n is equal to what? 8. Now, both sides of the equation don't have anything looking the same. Like in the other question, it had a man on this side and a man on this side. The equal sign come like a little separation line between the two pictures. It would be nice if there was some similarity between both of them, but there could be. 2 to the power n is 2 to the power n. We can't really do anything here. But isn't 8 the same thing as 2 to the power something? Go back to your tables from last week. 2 to the power something will give you 8. Well, what is that thing? 2 to the power what thing? Samaya, sorry, correct? Maria, correct. Right. Isn't 8 the same thing as 2 to the power 3? Sian, not wrong. Remember, 2 to the power 3 is 8. Go back to your table. Go back to your table. So now you have something and something that's similar on each side. You have a 2 on one side and a 2 on the other side. This come like the sun and this come like the little box. So if the 2 and the 2 is equal, shouldn't these two things also be equal? So who could tell me what's the value of n? Don't overthink it. How much is n? N is obviously 3. Because if the 2 and the 2 in the same position and they are equal to each other, then the powers which are in the same position should also be equal to each other. You think you are going to try part B for me? Take down the working for A and send the answer for part B. I really want to encourage you all not to overthink these things. They're supposed to be simple because it's going to, and these questions is coming CXC, and these same exact questions is coming CXC. So for this one, it's 3 to the power n, but if you look back in your table, 81 is the same thing as 3 to the power 4, right? So if the 3 and the 3 are equal because they are in the same position, then the n and the 4 are equal to each other. So n is equal to 4. This was the final answer I wanted. Some people were sending 3 to the power 4, but that's not the final answer. You have to extract the value of n for the examiner because those were the instructions, solving for n. So part C, send your answers. Let's go. Let me see if you fall for this trick here. Josie, correct. Maria, correct. A good few people were correct. I know I missed some people. All right, so I guess I could work out this one. That's a hard one, right? Here's 4 to the power n. Now, lucky for us, you already have a 4 on this side, so that's good news. But a power is missing. But we all know when you have something by itself, its power is automatically 1, right? So 4 and the 4 are in the same position. So that means these two are equal to each other. N is equal to 1. Try part D. That's a trick question. Tell me something. Is 3 the same thing as 1 over 3? Is that the same thing? The answer is clearly no, right? Because if somebody owe you $3 and they give you 1/3 of a dollar, you'll be pretty mad, right? Because they are not the same. So I know in part D, you're seeing a 3 and a 3. So your brain say, hey, 3 and 3, they have to be the same. But 3 is not the same thing as 1 over 3. That's 1/3, right? It only looking similar. For you to make the comparison, the 3 must be on top in both sides here. So it's 3 to the power n, but this 3 is underneath. But I'm not too sure if I went through this, right? Or I made it clear. If I had 3 to the power minus 2, right? Remember, if you throw it underneath, the power will become positive. So, and of course, you can reverse it. I remember saying that, right? But it may not have stuck. So if I have 3 to the power minus 1, if I throw it underneath, it becomes 3 to the power positive 1. But I don't even have to put the positive 1. So does everyone agree that 1/3 is the same thing as 3 to the power minus 1? I can throw away this guy and replace him with 3 to the power minus 1. In other words, 3 to the power minus 1 is the same thing as 1/3. So now you can update your vocabulary when you all go out in public. Like if there's a birthday party and you want 1/3 of the cake, you can say, instead of saying, I would like 1/3 of the cake, you can say, I would like 3 to the power minus 1 of the cake. And I guarantee you, you'll be the most popular person at the party, right? As they throw you out. Okay, so the 3 and the 3 are in the same position now, and it's 3 and 3. So that means the n and the minus 1 are now equal to each other. N is equal to minus 1, right? That's the final answer. N is equal to the power minus 1. Right? For a lot of people did get it correct, but quite a lot of people did get it wrong. For those who got it wrong, at least let me know, hey, you got it, you understood where you went wrong. All right, so let's move on. Let's see what happens. All right, so you leave Port of Spain with 2 bottles of water and you begin to walk to that bird sanctuary because you can't drive, right? Everything is back-to-back traffic. That's the flyover when you're leaving Port of Spain, yeah? For those who know Port of Spain. All right, so you made it to the bird sanctuary. All right, so have a few boats. It seems that other people have the same plan that you have, but that's understandable, right? All right, so let's try some questions here. Let's make these questions a little bit harder now. Not much harder, but you have to know a little bit of algebra here to get it out. When you have, for those who reach video number 5, right? I'm gonna give you a little introduction. If I have 2 to the 2x, and this is equal to 10, right? And I ask you to solve for x. That means you want x alone on one side and everyone else on the other side. What do you have in between here and here? How there's nothing? I know I keep asking the same question, but I just wanted to stick in your head, right? Well, what do you have in between here? A secret multiply, right? So this is really 2 multiplied by x is equal to 10. Whenever you are trying to solve for x, what you have to do is you grab the multiply and you throw it across the equal sign. And anytime you throw across a multiply, when it lands on the other side, it becomes the opposite. So the opposite of, no, it's not a minus. When you throw across a multiply, you always get a divide. But the sign does not change. This is positive 2, but when he lands on the other side, he's still positive 2. It's just that the multiply changed to a divide. So 10 divided by 2 is 5. So x is equal to 5. You're going to be bouncing that up over and over today. In other words, if I have 3x is equal to 27, and I ask you to solve for x, because this 3 is touching the x and he's a secret multiply, when I throw him over, he becomes a divide. 27 divided by 3 is 9, right? So you're going to be seeing that over and over today. You don't have to take it up, right? Right. And of course, you're going to bounce that up as you do the homework. Quick question. If I go back to this scenario now, and I have 2 people on this side and 2 people on this side, and on the next picture, and and you have the sun here. And I have only one person here. It has no space for another person. That the next picture intentionally leaves out the second person. Is it possible to figure out what goes here? Is that possible in maths? That's no, right? Because it's 2 completely different pictures. And there is no space for another person. So in a case like that, you cannot make a comparison between the 2 and figure out what goes at the question mark. However, if you erase this person, then it's possible to make a comparison because there's a similarity now between the 2 pictures. That's going to apply to this situation. Let's do part number 1. You have 2 to the power 3x multiply, keyword multiply, right? That's, keep your eye on this rule here. Multiply by 2 to the power 2x is equal to 2 to the power 8. This come like the picture with the 2 men and 1 man on the other side. Here you have 2 people and here you have 1 person. There's no way you can make a comparison between both sides unless we combine these 2 values to get 1 value. What do you all think there? And the examiner has been so nice to us that it is possible to squish these 2 together. The bases are the same and it's a multiply. When the bases are the same and it's a multiply, you put back the base. And what can you do to the powers? You have to add the powers. How much is 3x plus 2x? If you have 3 apples and you add 2 apples, how much apples do you have? You have 5 apples, right? But instead of the word apples, we're going to use x. 3x plus 2x is 5x. So you see what we did? We squished these 2 together to get 1 value. So now you have 1 man on this side and 1 man on this side. The 2 and the 2 in the same position, right? Right? The 2 and the 2 in the same position. Therefore, what should be equal to each other? 5x is equal to 8. So 5x is equal to 8. Is it possible to solve for x now? Yes. This 5 is a multiply, throw it across, you get a divide. So the final answer is x is equal to 8 over 5. Take down the working for the first one, right?